Hi, Assalamualaikum warahmatullahi wabarakatuh. Today we're gonna discuss on how to solve these types of question, which is the polynomial evaluation. So the question asks us to evaluate 3x squared plus x plus 1 at x is equals to 2 by using the given pseudocode above. So how we gonna solve this question, these questions? First, we must state all the important information given in the question. So the question has given the general form, which is an times x to the power of n plus an minus 1 times x to the power of n minus 1 plus plus a1 times x plus a naught a0 with the condition x is equal to c, and the pseudocode are stated as given. So after we state all the important information, we must then compare both the general form and the question form, which is the 3x squared plus x plus 1, to get the specific information such as the value of n, the value of c, the value of a naught, and the value of a1. So to compare, we must look for the same positions of the term in the series, which is in the general form a naught, while in the question form is 1. So both share the same position in the series, so we can indicate that a naught is equals to 1. In the general form, we can see that a1 times x share the same positions with the variable x in the question form. So with that information, we can state that the a1 is actually equal to 1, because in front of the x in the question form there is a number 1 there. So a1 is equal to 1. Then we see in the first term of the series for the general form an times x to the power of n with the same position in the question form 3x squared, we can indicate that the n is equals to 2. The value n is actually 2, because they share the same position with both in the general form and the question form. So we got the a naught, which is 1, then n, which is the value of 2, c is equals to 2, because in the question state up there where the final value of y is the value of the polynomial at x is equal to c. So x is equal to c, and in the question they said at x is equal to 2. So secara tak langsung c adalah sama dengan 2. So we get all the information after compare. Then we must move to the pseudocode. Untuk pseudocode, general pseudocode telah diberi di dalam soalan. Kita hanya tinggal menggantikan sahaja semua variable dengan nilai yang telah kita dapat tadi. So for the first line of the pseudocode, we initiate power equals to 1, and we also initiate y equals to a naught, which is the value of 1, because we has already found the a naught is 1. Then the pseudocode will going to the for loop. The for loop will start with the condition I equals to 1 until I equals to n, which is n, we got value of 2. So the loop will start with I equals to 1. So for the I equals to 1, the power is equals to power times c, which is power we has initiate in the first line, which is 1. So 1 times c. C, the value c is 2. We got the values 2 from comparison between the general form and the question form. So power sama dengan 1 darab 2. So jawapannya 2. Lepas tu dia akan turun kepada line seterusnya, iaitu y sama dengan y plus a1 times power, which is y. We have initiate the value, which is a naught, which is 1. So y equals to 1. So 1 plus ai. I is 1, because this is for the first conditions of the loop. I equals to 1. So I 1. So a1 times power. The value of power we get from the previous line, which is 2. So y equals to 1 plus 1 times 2. and the answer is 3. So at this line, the y has the value of 3. Then the loop will go for the next value of I, which is I equals to 2. The loop doesn't end yet because condition is from I equals to 1 until I equals to n, which is 2. For the I equals to 2, same thing, repeat, is power equals to power times c. At this point, power is equals to 2 because the value of power from the previous loop has been carried to the next loop for the I equals to 2. So power times c, so 2 times 2 equals to 4, then y is equals to y plus ai times power, which is 3. Y is 3 because the value of 3 is carried by the previous loop. So 3 plus 3 times 4 is equals to 15. Then after that the loop will end, and then the pseudocode will return y, which y is equals to 15. For the question B, the question asks us to calculate how many multiplication and addition steps involved in the pseudocode. Exclude the increment of the loop variable. So for the first loop, the number of addition involved is actually only 1 in the line 5, which is y equals to y plus ai. And for the multiplication, there is only 2 for the line 4 and line 5, which is power times c and ai times power for each for the first loop. So for the first loop, there is only 1 addition and 2 multiplication operation. However, the scenario happened in the for loop until n, which is the loop will repeat it until the n times. So the total number of multiplications operation in the pseudocode will be 2n times, and the addition will be n times, since 1 times n and 2 times n. Now we move to question 2. For this question 2, we still use the same equation as the previous question, which is 3x squared plus x plus 1 with the same condition, which is x is equals to 2. But this time, we will use the Horner method. Horner method is actually quite the same with the method we use for the question 1, but it has a slight of difference in terms of the pseudocode itself. As you can see, the pseudocode given in the question is a bit shorter compared to the previous pseudocode. So for the question A, we will still use the same step as the previous question, which is first we must state all the important info given in the question, which is quite the same. 3x squared plus x plus 1 with the condition x is equals to 2, and the general form is an times x to the power of n plus an minus 1 times x to the power of n minus 1 plus dot 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 a1 plus a1x plus a0. Then we must start compare both general form and the question form to get the specific information we needed, which is the value of a0 and C and A1. So untuk compare, sama seperti soalan 1 tadi, we will look for the same positions of the term in the series, which is A0, you can see is equals to 1, and then A1 times X is same with the X, so basically A1 is value of 1, then for the N is equals to 2, because of the positions of the 3x squared and the an times x to the power of n share the same position, and we can indicate that n is equals to 2. Then we will start look through the pseudocode itself. So the pseudocode for the Horner method start with we initiate y equals to an, which is the value is 3. How we get an is equals to 3? Because it is the result of the comparison between general form and the equation form for the first term, which is an times x to the power of n is equals to 3x squared. And when we compare, we can see that an is actually is equals to 3. So with that information, we can state that an is actually is equals to 3. Thus, y is actually is equals to 3 for the first line of the pseudocode. Then it will go to the loop for loop, which is start with I equals to 1 until I equals to n, which is n is equals to 2. So for the first loop, which is I equals to 1, the formula is y equals to y times c, which is y, the value of 3 times c, which is 2. So 3 times 2 plus a n minus 1, which is n ialah 2. 2 minus 1 is 1. So the complete equation will be y equals to 3 times 2 plus 1. So the answer is equals to 7. Then the loop will repeat for the I equals to n, which is 2. Same process, which is y equals to y times c plus a n minus 1. The complete equation will be 7 times 2 plus 1 equals to 15. And then the loop will end and the pseudocode will return y, which is value of 15. So next we move to the question B. The question asks how many multiplication and addition operation used in the algorithm. Exclude the increment of the loop variable. So the multiplication operation only involved in the loop section, which is y times c, which is occur 1 per loop. And the additional also only we can see in the loop section, which occurred only 1 times, c plus a n minus 1. Because of the loop is continue until I equals to n, so we can conclude that this scenario has the multiplication operation as many as 1 times n times, and additional operation as many as 1 times n times. So for the whole pseudocode, there is only n multiplication and n additional operation. That's all. Thank you.